In this video I will show you how we can create a storage for our cluster. And for that purpose we will use Ceph. So Ceph as a shared file system will enable us to use the local storage of our nodes, the local disks, to store the data like our VM disks and container volumes. So the data will be shared across our nodes and also replicated. And Ceph uses the local disks of our individual hosts for that. So there is no need for separate storage networks or for a separate network attached storage in order to improve high availability and redundancy. So yeah, let's just get started. As shown in the previous videos, my cluster here consists of 3 nodes, and I've added another disk to every node. So in one case, really a physical hardware, a real SSD, and on my 2 virtualized systems, these are just virtual disks, which will be okay for these test scenarios. Yeah, and to get started with the configuration of Ceph, I need to select the node and switch to the Ceph section. And as you can see, the first step is to install Ceph. After clicking on the install button, we get the following dialog. Just like when using Proxmox virtual environment and Proxmox backup server, we can choose between the enterprise repositories and the no subscription repositories, which require no valid license. In addition, we also have the option to install a specific version if needed, and then we can just start the installation via this button down here. We just need to confirm the installation of the packages, and after a short wait, Ceph was installed successfully. And this installation of Ceph needs to be done on every cluster member. So basically just selecting the right repositories, the version if needed, and starting the installation. And on the first node on which we install Ceph, we also need to select the network. In that case there is only one. In a production environment it is recommended to use a separate network for Ceph. And since we are talking about storage here, low latency is also important. Yeah, and as we can see here, this node will be our first Ceph monitor. Additional ones are recommended. And we can also create new ones at any time. These Ceph monitors create a so-called cluster map in the background. And for example, they are responsible for managing the cluster status. So of course we will create more later on. One that is running on each node. Cause yeah, if we only have one monitor on node 3 here, and this one goes down, we also have no monitor which manages our cluster status. And of course that wouldn't be great. But as far as this dialog is concerned, I can just continue. As we can see, the installation was successful, and we also see the additional steps. Of course I will also show you these in this video. And as mentioned, on the other nodes the installation is basically the same, but we don't need to select the cluster network again. So as we can see here, we then get this information that the configuration has already been initialized. So now I have installed Ceph on every node here, and therefore I can continue with the configuration. So I will scroll down a bit and select monitor here under Ceph. And as we have seen during the installation, it is recommended to create more monitors. To be precise, 3 monitors as a minimum. So in my case, with my 3 node cluster, 1 monitor on every node. And I can just do that by clicking on the create button and selecting the corresponding host. So Proxmox 4 and also Proxmox 5. So now we have 3 monitors, each one has the status running. So for example, if one host is down, 2 other monitors will keep running. And as a next step, we will configure the Ceph OSDs, the object storage daemons, which manage the data on our local storage, our local disks, and provide access to this data over the network. And in order to configure that, I will switch to the OSD section, and here I can create a new OSD. In the end, I just need to select a local disk that isn't in use. So if your disk isn't visible here, you can also switch to the disk section. Here you can check if your disk is in use, and you can also see if there are any partitions on it. And in addition to that, it's also possible to wipe the disk. And if your disk doesn't contain any partitions, doesn't contain any data and isn't in use, it should be visible here after clicking on Create OSD. So in my case, this disk is the right one for node 5, and I will just create the OSD. Yeah, and after clicking on the reload button, we can see that the OSD was created with success, and it's also up. So I will just create an OSD for the other nodes as well, also just by clicking on Create OSD and selecting the right disk. And after refreshing, it's also visible here and has the status up. And of course, I also created an OSD on the last node. So just as a small recap, Ceph is now installed on every node here. 3 monitors are up and running, which are responsible for managing the cluster state. And in addition to that, we created 3 OSDs that manage the data on our local storage with redundancy and provide access to the data over the network. But yeah, until now there's still no storage here on our nodes that we can use to create VMs on containers, which can be migrated to other hosts. So what do we need for that? To achieve that, we need to create a pool. This can also be done here in the Ceph section, just by opening the following dialog. Then we just need to provide a name. And I will also enable the advanced options, cause there are 2 settings which are important for data replication: size and minimal size. Let's first talk about the size parameter. Here, this default option 3 means that 3 copies of each object that is stored will be created. And since minimal size is set to 2 by default, it is absolutely necessary that 2 copies of each object exist. Otherwise, Ceph will start to block I/O operations. So yeah, for my test environment here, I will keep the default settings and create the Ceph pool. And after a short wait, the pool was created. And we also see that it's available here, just like any other storage. And this is also the case for the other nodes, as you can see here. And now we could use this pool, this storage, to store VM disks and container volumes. So now our basic Ceph configuration has been completed. And for example, if we create a VM disk, on this storage the data will be replicated to the other nodes. In the end, to the other physical disks inside of our nodes that are managed by the object storage daemons that we configured earlier. And now, after creating the storage that can be accessed by all nodes, we can have a look at several other interesting topics, like migrating VMs from one host to another, and also simulating node failures, in order to check what will happen to a VM when a node gets down. And of course, we will explore that together in the next videos.